Hello everyone! Today we will have a new lesson about truth table. A truth table is a mathematical table used in logic, specifically in connection with the Boolean algebra, Boolean functions, and propositional calculus, which sets out the functional values of logical expressions on each of their functional arguments, that is, for each combination of values taken by their logical variables. In particular, truth tables can be used to show whether a propositional expression is true for all legitimate input values, that is, logically valid. A truth table has one column for each input variable, for example, P and Q, and one final column showing all of the possible results of the logical operation that the table represents, for example, P XOR Q. Each row of the truth table contains one possible configuration of the input variables. For instance, P is equal to true, Q is equal to false, and the result of the operation for those values. Ludwig Wittgenstein is generally credited with inventing and popularizing the truth table in this Tractatus Logico-Philosophicus, which was completed in 1918 and published in 1921. Such a system was also independently proposed in 1921 by Emil Leon Post. An even earlier iteration of the truth table has also been found in unpublished manuscripts by Charles Sanders Peirce from 1893, antedating both publications by nearly 30 years. Let's talk about first the unary operations. There are four unary operations. First, logical true, which is always true. Logical false, which is never true, or unary falsum. Next is logical identity or unary identity, and logical negation or unary negation. The logical true. The output value is always true, regardless of the input value of P. For example, under the P is true, then the value or truth table is true. And then P is also false, then the table is true. For the logical false, the output value is never true. That is always false regardless of the input value of P. For example, of the truth table, logical false. True is equal to false, and F or false is equals also to false. For the logical identity is an operation on one logical value P for which the output value remains P. The truth table for the logical identity operator is as follows. T is equal to T or true, then F is equal to F or false. For logical negation is an operation on one logical value, typically the value of a proposition that produces a value of true if its operand is false and a value of false if its operand is true. The truth table for not P, also written as this, as you can see on the screen, is as follows. So for the logical negation truth table, T or true is equal to false, then F or false is equals to true or T. Let's proceed to binary operations. Truth table for all binary logical operators are logical conjunction and logical disjunction or logical implication, logical equality, exclusive disjunction, logical NAND, logical NOR. There are 16 possible truth functions of two binary variables. Truth table for all binary logical operators. Here is an extended truth table giving definition of all possible truth functions of two Boolean variables P and Q. So here is the sample truth table for the binary operations. Where T is equal to true, F is equal to false. The com row indicates whether an operator is commutative. The ADJ or edge row shows the operators such that P or OPQ is equal to Q or up to P. The neg row shows the operator up to such that P OPQ is equal to not Q up to P. The dual row shows the dual operation obtained by interchanging T with F and AND with OR. The LID row shows the operator's left identities if it has any values such that I of Q is equal to Q. The RID row shows the operator's right identities if it has any values I such that P of I is equal to P. The four combinations of input values for P, Q are read by row from the table above. The output function for each P, Q combination can be read by row from the table. For the key, the following table is oriented by column rather than by row. There are 4 columns rather than 4 rows to display the rows or the 4 combinations of P or Q as input. For example, P is true, true, false, false, or T, T, F, F. Then Q is true, false, or T, F, T, F. There are 16 rows in this key, 1 row for each binary function of the two binary variables P, Q. For example, in row 2 of this key, the value of converse non-implication is solely T. For the column denoted by the unique combination P is equal to F, then Q is equal to T, while in row 2 the value of that operation is F for the 3 remaining columns of P and Q. The output row for an implication is thus 2 is false, false, true, false, or F, F, T, F, and the 16 row key is like this. As you can see with the screen, logical operators can also be visualized using Venn diagrams. So as you can see to the sample screen, the operation name are contradiction, logical NOR, converse non-implication, negation, material non-implication, negation, exclusive disjunction, logical NAND, logical conjunction, logical biconditional, projection function, material implication, projection function, converse implication, logical disjunction, and tautology. For the logical conjunction or AND, logical conjunction is an operation on two logical values, typically the values of two propositions, that produces a value of true if both of its operands are true. The truth table for P and Q, also written as like this in the screen, is as follows. Here are the logical conjunction. T, and T is equal to T, T and F is equal to F, F and T is equal to F, and F and F is equal to F. That is for the logical conjunction. In ordinary language terms, if both P and Q are true, then the conjunction is true. For all other assignments of logical values to P and to Q, the conjunction is false. It can also be said that if P, then the conjunction of Q, otherwise, the conjunction is P. For logical disjunction logical disjunction is an operation on two logical values, typically the values of two propositions, that produces a value of true if at least one of its operands is true. The truth table for P or Q, also written as you can see by the screen, is as follows. Stated in English, if P, then or logical or P, Q is P, otherwise the logical disjunction is Q. The truth table for logical disjunction is T and T is equal to T, T and F is equal to T, F and T is equal to T, and F is equal to F. Next is the logical implication. Logical implication and the material conditional are both associated with an operation on two logical values, typically the values of two propositions, which produces a value of false if the first operand is true and the second operand is false, and a value of true otherwise. The truth table associated with the logical implication P implies Q, or symbolized as you can see on the screen, is as follows. T and T is equal to T, T and F is equal to F, F and T is equal to T, and F is equal to T. So that's the truth table for logical implication. The truth table associated with the material conditional if P then Q is as follows. So for the material conditional truth table, T and T is equal to T, T and F is equal to F, F and T is equal to T, and F is equal to T. It may also be useful to know that P for the material conditional are equivalent to the following on the screen. For logical equality, also known as biconditional or exclusive NOR, is an operation on two logical values, typically the values of two propositions, that produces a value of true if both operands are false or both operands are true. So the truth table for P, X, NOR, Q, also written as you can see on the screen, is as follows. For the logical equality truth table, T and T is equal to T, T and F is equal to F, F and T is equal to F, F and F is equal to T. So P equality of Q is true if P and Q have the same truth value, both true or both false, and false if they have different truth values. Then exclusive disjunction. It is an operation on two logical values, typically the values of two propositions, that produces a value of true if one but not both of its operands is true. So the truth table for P, XOR Q is as follows. T is equal to T and T is equal to F, T and F is equal to T, F and T is equal to T, F and F is equal to F. So that's the truth table for exclusive disjunction. For two propositions, XOR can also be written as for the following on the screen. Then logical NAND. The logical NAND is an operation on two logical values, typically the values of two propositions, that produces a value of false if both of its operands are true. In other words, it produces a value of true if at least one of its operands is false. The truth table for P NAND Q is as follows. P and T is equal to F, T and F is equal to T, F and T is equal to T, F and F is equal to T. So that's the truth table for logical NAND. It is frequently useful to express a logical operation as a compound operation, that is, as an operation that is built up or composed from other operations. Many such compositions are possible, depending on the operations that are taken as basic or primitive and the operations that are taken as composite or derivative. In the case of logical NAND, it is clearly expressible as a compound of NOT and AND. The negation of a conjunction and the disjunction of negations can be tabulated as follows. So take a look at the screen. For the truth table of negation of conjunction and disjunction of negations. Logical NOR. The logical NOR is an operation on two logical values, typically the values of two propositions, that produces a value of true if both of its operands are false. In other words, it produces a value of false if at least one of its operands is true. Arrow down is also known as the Peirce arrow after its inventor, Charles Sanders Peirce, and is a sole-sufficient operator. The truth table for P NOR Q is as follows. P and T is equal to F, T and F is equal to F, F and T is equal to F, F and F is equal to T. So that's the truth table for logical NOR. The negation of a disjunction and the conjunction of negation can be tabulated as follows. Inspection of the tabular derivations for NAND and NOR under each assignment of logical values to the functional arguments P and Q produces the identical patterns of functional values, as you can see on the screen. Thus, the first and second expressions in each pair are logically equivalent and may be substituted for each other in all contexts that pertain solely to their logical values. This equivalence is one of De Morgan's laws. Let's talk about the applications of those logical truth table. Truth table for most commonly used logical operators. Condensed truth tables for binary operators. Truth tables in digital logic, and applications of truth tables in digital electronics. So that's all for the discussion about the truth table or logical truth table. Thank you for watching and have a nice day.